This is a fully physically simulated character Unity engine that can sprint like a human. And this video is a story of how I did it on my crappy laptop. Enjoy! Over the past decade, I have always wanted to create a physics-based natural moving character in the game. I have tried it more than once in the past. About twice, but results were not even close to what I envisioned. Complete failure actually. Many years have passed since my last attempt. New research papers have been published, new tools have been developed. My experience has instilled a lot of knowledge in the neurons in my brain. And I'm stuck in my room waiting for my working visa, so I feel like it is finally the time for me to take on this boss level challenge once again. I will power through it, whatever it takes. Besides, anything that costs me a lot of money and potentially make me homeless. Our goal here is to find a training procedure that guarantees active Ragdoll can learn to imitate reference animation within a reasonable time frame, and also without the help of external force. Alright, first thing first, I'll need to explain some concepts first, okay? Don't worry, I'll make it fast.
That's what she said!
Alright, here goes. First, for those who don't know what active Ragdoll or physics-based character means, just imagine it as a robot-like game character which consists of joints with a certain degree of freedom and links that can physically contact other physical objects. The only way to make it move in any way is to apply torque to its joints. And the task here is called physics-based character motion imitation learning, quite a name, which simply means training the active Ragdoll, our agent, to imitate the given animation by rotating its joints and using reaction force of the ground. Next, reinforcement learning. Well, it's like how your girlfriend treats you according to your behavior. If you buy her some flowers on Valentine's Day, you may get a kiss. If you buy her a ring and propose, you may get to have sex with her until you two have a kid and finally get divorced. But if you see her eat donuts and you goes like,
"Eat your vegetables, fat ass,"
you are most likely get kicked in the nuts. The idea behind reinforcement learning is learning through trial and error. And our best action at any moment would be the one which gives us the best sum of the rewards across the future, rather than an instant maximum reward. Come on, you know this. Why the hell on earth did you ever choose to watch Titanic or go on a picnic with your girlfriend when you could just stay in your room and play Minecraft with your buddies? Because you know that after all those troubles, there will be some sweet, sweet rewards waiting for you at the end of the tunnel. If you know what I mean.
The kids don't know, but we do.
Anyway, in this experiment, we're going to use Unity's ML agent, which has a PPO algorithm implemented already. PPO stands for Proximum Policy Optimization. It's an unpolicy reinforcement learning algorithm based on the actor critic method, because it's hard to change your behavior if you don't even know how good you currently are. The actor critic method addresses this issue by introducing another neural network, the critic. Think about the critic as your best buddy, okay? As your best friend who probably knows too much about you. On-policy just means you learn only through trial and error of your current policy. Off-policy not only means you can learn from your past experience, but also means you can learn from others. So, that basically means off-policy is more sample efficient than on-policy, which would result in faster training. However, for the sake of saving time and brain cells to implement it, we'll just use this already working PPO here. I mean, even ChatGPT's last stage is trained using PPO, so who am I to disagree? And that is totally not an excuse. ML agent environment is notoriously hard for training physics-based character. Many have tried, but as far as I'm concerned, nobody have yet obtained any good result in it. So here I'll try to make the things work in 2D first, before I even consider to try 3D. We'll move steadily from easier to hard, because if you start with the hard stuff, you could end up like my uncle, divorced and leaving his car. Alrighty, that's all you need to know here. Now, enough talking. Let's get into the action. Download this, read this, testing, and good. Now, let's create our character. I'm using an add-on called Character Creator 2D. Don't know why about it, but not gonna bitch about it. So, this one, maybe this one, and yeah, I think it's alright, yeah. So now we can, whoa. hold on for a second. Huh. So, we have our character here. It's a Wonder Woman. Yeah, I like her because she's hot. Next, give her a physical body. Make sure she's really flexible. Seems the environment is ready. Then let's do a little test run, shall we? Here's what we're gonna do. Very basic stuff. At each time step, the agent takes its current state as input, including each joint's rotation and angular velocity, distance from hips to ground, plus agent's current running speed. Basically anything that could help him to complete the task. The output is only consists of target rotation and maximum joint strength for each configurable joint component, and then that component using a simplest version of PD controller to calculate the torque for the joint. Finally, we reward agent for running forward and not falling on its ass to the ground. For those who want to know more about the PD controller, I will leave some resources in the description. Alright, let's start the coding. Cool, all done, let's give it a try. Yep, so far so good. Next, DeepMimic. DeepMimic is like a baseline method for physics-based character motion imitation learning. Besides using PPO as the core learning algorithm, it also has another two key components: reference state initialization and early termination. Reference state initialization means at the beginning of each episode. An episode is a fixed time steps of simulation before we restart it. So at the beginning of an episode, before our character starts to move, we start our reference animation at a random time within its time length. Then, we copy the initial pose to agent's joints along with target angular velocities. The idea behind this mechanism is that we want to tell the agent what target animation looks like directly, without the need for agent to discover it. It's like when you're playing Souls-like game. Every time you die, you'll respawn near the checkpoint on the main road, right? You don't want to respawn and fall off the cliff right away, do you? Early termination is, instead of each episode have fixed time steps, we terminate the episode when character's body parts other than their feet touch the ground. Again, Souls-like game, when you are stuck at the bottom of a cliff, you naturally want to go back to the closest checkpoint, isn't it? Now, we need to update our implementation detail a bit. Besides anything I just mentioned about DeepMimic, in addition to the same thing our agent currently uses, we also need to feed the state of the reference motion to the input, which tells agent what animation to mimic. Second, we add an additional reward function that tells agent how good it imitates reference motion. Okay, let's do it. Done, now we test it. Nope, can't tell any difference from last run. Gee, what the hell is this crap? Oh my goodness, it's not even moving forward. Come on now, you need to learn how to ballet. All I want is you to walk. Oh my god, you just love the ballet, do you? Oh my goddess, how can you learn how to do a backflip before you even learn how to walk? It just... how? No. It's not working, just like last time. Come on man, think. Why? Why is that? The leg is kicking all over the place. So maybe, if I make the agent's action space small enough, then they can learn something. As my elementary school teacher used to say, if we can't make them smarter, then we make the task stupider. So we just simply shrink the degree of freedom for each joint to the range of your grandma. Oh crap, it's working. I think it's working. Let's train it longer for next one. Yeah, there we go. Our first non-trivial success. Yes indeed. We successfully make Wonder Woman to walk like when she's in her 80s. Which, she's walking alright, but not really robust. And I also tried so many other configurations, but with joint's angle being so limited, the ability for agent to balance itself can only be as good as this. Besides, this trick is completely useless against the motions which require a large range of the movement, like running and sprint. So, we need to try something else. Well, that works for a bit. I mean, at least it's working now, isn't it? Let's just see how far we can take this idea, alright? So in the light of simplifying the task for the agent, I came up with this brilliant idea. I call it IK2PD. Idea behind IK2PD is, instead of letting agent to control each joint directly, we let it control the IK target for each limb, and IK solver will give us target rotation for each joint on it. Then we'll send those rotation to PD controller. With this, we can control active ragdoll directly with IK. I know, genius, right? Idea came from computer 3D animation. It's like, usually using IK is much easier than FK when enemy's character's limbs, so makes sense, right? Well, there's only one way to find out. Let's start by checking some formulas. And whew, finally done. Have to say it's 4 times harder than expected. Now, let's see. Right arm, left leg. Cool, seems good. And since our agent is so dumb, it can only output float between -1 and 1. So, I used the polar coordinate system to map its outputs to IK target's positions. I have high confidence in this approach. As you can see here, I'm only using my mouse to control its leg, and it can work already. Sort of. Left step, right step, crap, whee! Alright, enough testing, let's try. Well, fantastic! Did that just make things much worse? Real brilliant idea you got. Just wasted a week of your life, no big deal. Now, how about you just stop, okay? Stop! And think about what are the main problems. Why it is so hard to get it right.
Think, goddammit, think!
So, the core problem is, in physics-based character motion imitation learning with early termination, if the agent is randomly initialized and attempts to imitate a given reference motion, like a walk animation, it will likely only learn how to walk awkwardly and be unable to modify its gait to match the reference motion. This is because, first, there could be countless ways for the agent to walk, but only one way for agent to walk like the reference motion. Secondly, in the presence of early termination, the reward function will prioritize the very first successful working behavior agent finds over attempting to match the reference motion while falling on its ass to the ground. Combine those two situations together, then you'll lead the agent right into the bottom of a cliff named local optima, and there's no getting out from that. It's like Homer Simpson trying to run a marathon. We all know that he would cave into the first donut shop he encounters.
No!
So, now the problems are clear. But how am I going to solve those damn things? Did I do the best I could already? Should I just call it a day and let other guys to figure this out? No, not today. Not again. I'll find the answer, no matter what. Later that night, I had been pacing back and forth in my room for hours. My thoughts were consumed with the problem that had plagued me like forever. And I suddenly realized that I forgot to eat lunch and dinner. Could be I ate too much for breakfast, but none of that matters. I demanded myself an answer. Today. My mind was consumed with the problem. Every thought leading me drowning in the sea of darkness and despair. The weight of it all made me feel suffocated, but also could just be my friend who cooks downstairs forgot to turn on the range hood. As I keep running circles in my head, the world around me seems turning darker and darker. Every tick of that damn clock sounds like a pen being tapped on the table by the judge. Then suddenly, out of nowhere, something happened. It was like a spark had ignited within my mind, illuminating the darkness and despair that had been suffocating me for so long. It was there, right in front of me. The solution was so simple, so obvious. I couldn't believe I hadn't seen it before. Behold, the baby walker!
What?
Let me explain. The idea is, at the beginning of the training, we prevent agent from falling on the ground by adding some support force on its hips, so it can learn the rhythm of the reference motion by mapping its action to a range that closer align with reference motion's trajectory. Then, we gradually decrease the amount of assistance agent receives, each time decrease it to a point which agent can barely not fall. So eventually, agent will learn how to balance itself based on the rhythm of the reference motion. You probably guessed it, that's right. It's just like toddlers using baby walker to learn how to walk. Or like little kids using training wheel to learn how to ride a bike. Or, here's a better metaphor. It's like practice skeet shooting. We first align the gun point with target's moving trajectory. Then we gradually learn how to shoot from greater distance from the target. I mean, it makes sense, right? You need a swim ring to learn how to swim properly. Otherwise, like my dad used to just throw me in the river without swim ring, and I end up only learn how to swim like a guinea pig. So, give your kids a swim ring for help them learn how to swim, alright? Unless you want to get rid of them. I think I'm gonna call my parents. For those who are interested in the technical detail, I prevent agent from falling on the ground by using a stable version of PD controller for agent's hips to follow its reference rotation and word vertical position. Last but not least, I'll name this method rope, short for rhythm-oriented progressive elevation. Since this method it works like a rope that lifts up our character, and also there is this fancy catchy naming rule that rules the machine learning field, and hey, I didn't make the rules, so rope it is. That is clear, now let the coding begin. Okay, done, easy code. Now, the moment of truth. So, in our first training session, I increased the magnitude of the helping force all the way up. Apparently, this task is easy enough for agent to learn how to walk like a stringed puppet. Sim agent without helping force is not even close. Now, let's lower the helping force and run the second training session. Seems better, but not too much. Let's go to the next training session. Come on, just a little more, you can almost not fall now. Oh shit, there's hope. It can almost work now. Please, please don't fail me. Just a little more, that's all I'm asking. Oh my god, it worked. Oh my god, it worked. Holy shit! Oh, I'm so happy right now, I'm so happy. The joy, just too fucking much. I want to kill myself. Oh, gee. I can't believe it. It's like seeing your own daughter take her very first step. I succeed. I win. Yes! All those time and efforts have not been wasted. Yes! I can finally spend weekends to editing the video instead of going to my friend's party and potentially getting laid. Yeah! Decent result already, but let's not stop here, okay? Let's train our Wonder Woman to run. Nah, to hell with it. To sprint. Let's... Well, the training took a while, since sprint is harder than walk, duh. But still succeed. It seems my rope method is really robust, since it can produce a really smooth training curve. You can also feel this smoothness through the curvature of her legs. Movement. Alright now, since we have obtained some good results and a lot of data, so let me write a paper about it. But before that, I probably should have done more research. You know, just in case someone else already have a similar method or even better solution. Seen this before? Nothing new? Interesting but not really related. Hey, what would you know? Ubisoft have some research on this. Okay. Typical setup. Wait a second. PD corrective. Yes! Of course! It's even better than my rope method. Ah crap, it's so obvious. Why the hell I didn't think of this? Simply put, the key idea this paper proposed is that instead of letting agent to predict the target rotation for each joint directly, we're using joint rotation from reference motion as baseline target rotation. Of course, that alone is not enough to keep agent balanced on the ground, as you can see here when we decrease the help force on its hips. but it already follows the rhythm of the reference motion, which simplifies the task dramatically, since the agent don't need to search and learn the rhythm of the reference motion at all. So all that's left for agent to do is just to output some corrective target rotations, then add on top of the baseline target rotations for agent to maintain balance. That's it. Not only this method can reduce the training time dramatically, it can also shrink the model's size substantially. It's tiny and extremely efficient.
That's what she said.
Implementation should be straightforward enough. Let's do it. Done, piece of cake. Let's see how good this method really is. Oh god, this is good. So good. So much better than expected. This method reduces the training time by at least 5 times. Not only that, it also reduces the size of model by at least 3 times. And not only that, it's also quite robust. Not only that, and my laptop dead. Ah, crap. Just for the record, I also tried using my rope method together with this method. It will still train successfully, but training takes a little bit longer than if I didn't use it. Why? Well, it's likely because with this better method in this 2D environment, even the hardest task for the agent is already easy enough. So the time it takes for the agent to transfer its skill from an easy task to a harder one will take longer than let the agent to discover the skill in a harder task directly. I know, it feels like my efforts have gone to waste. But if I didn't find out what the core problems were myself, then I probably wouldn't have realized this would work better than DeepMimic in the first place. Besides, it doesn't mean that my rope method is completely useless. If things getting hard in 3D again, I'll come back to it, okay? Whew, that's a lot of work. Took me more than a month already. But now, since we have all those agents we just trained, let's build a squid game with them, shall we? We'll build my favorite squid game, red light, green light. First, we use some background which is free. Second, we add a countdown clock to cause anxiety. Then, we create some more characters. And... Ladies and gentlemen, welcome to the Squid Game! Allow me to introduce our contestants. Wonder Woman, Lady Crab, Miss OnlyFan, your new stepmom, Talent Stripper, Why Am I Running, Mad X, Every Guy's Fantasy, Childless Middle Age. The rule is simple. They have to stop when the music stops and cross the finish line before the time runs out. Otherwise, their husbands will be free from the marriage. Now, let the game begin!
3, 2, 1, go!
Whew, what a journey, what a journey. Lots of twists and turns, totally not what I originally imagined. Can't believe I've been taught a lesson by Ubisoft. Well, I guess if you spend some $1 million for research, you can find something useful. Either way, lesson learned, and the mission accomplished. Now, I'll need some time to plan my next project. I was thinking either continue this research in 3D, or build something with those large language models like ChatGPT. We'll see. Also, I need to find a better way to editing videos. Painful to say, but this one took me a month to make. With that much time, I can finish my next project already, which... yeah, not good. Hey, that's it. Hope you had fun like I did. Please like and subscribe for our next adventure. Bye, have a nice day.